Hi, I'm Jeff Fisher. And if you're watching this, then you're a developer interested in working with Google products using their APIs. More specifically, their APIs that use the Google Data Protocol. So, what is the Google Data Protocol, you might ask me? Well, before I can answer that, I have to go through some background information. I'm assuming here that you're familiar already with the technologies of HTTP and XML. Now, for a long time, websites have been looking at alternative ways of distributing their content in a more computer-friendly way. Computers are not very bright, so they need a little bit of help understanding our information as we see it. So let's look at a simple example, such as a blog site. So a blog site has a number of news articles that are displayed in a big list, and they have a summary, a title, who wrote them, when they wrote it. So just basic information. How might we represent this in a computer-friendly way? Well, the first attempt to solve this problem was RSS, but the thing I'm going to talk about today is the Atom syndication format. Atom is an XML-based approach to describing the data on these websites and making it easy for computers to parse this information out. So at the basic level, you have a feed element that contains multiple entries, and each entry will contain all the metadata associated with a post on this blog site. Well, that's great, because now we have this compact way of describing all the content on a blog. But what if I want to create a program that edits this blog and not just, reads it? Well, I could create an entirely new mechanism to do this and have it be drastically different than this feed mechanism we've already described, or I could try to reuse it. Well, if I'm going to reuse this format that describes my posts all nicely in XML, how would I transmit this data to the server? Since these posts are already retrieved using HTTP, we can just use HTTP to edit and delete this content as well as create new content as well. So great, we can reuse what we already have and just make use of other verbs in HTTP like put, post, and delete. And we have now a full cycle way of managing blog content by just editing the feed, basically. Well, what if my site doesn't have blog entries? What if it's not a blog? What if it's something like a calendar or a spreadsheet? How would I represent that data? Well, you could try to do it in a new way, or we could try to use this Atom method again. And if we use the Atom method, that's exactly what Google Data tries to do. So let me show you an example of what an Atom feed looks like. An Atom feed is XML, like we said before, and it contains entries. Each feed has its own metadata and as well as each entry. And you'll also notice that each entry has a unique identifier that makes it distinct from all other entries on the site, as well as some information used to edit it. So once we take this and we make it into an editable form, we call this the Atom Publishing Protocol. And the Atom Publishing Protocol abstracts each of these entries and turns them into resources. And now these resources can either be a traditional text resource, or they can be a media resource, such as an image file or a video. It also reuses these HTTP requests, like we've already discussed, to manipulate this data, and then it uses the HTTP response codes in order to tell if this operation was successful or had errors or requires authentication. Now, this is what is usually referred to as a RESTful protocol that uses the RESTful semantics in order to modify these resources, and each request is therefore independently of each other request and doesn't require any additional context like a session to know what to do. So here we have an example post of what it is to create an entry on the blog using AtomPub. And you'll notice there's some authorization, there is some other bits of metadata, but basically all we're posting is the Atom entry, just like we would get in the Atom feed. Once we have posted this bit of data, we have created this entry, and we get back the entry as we created it with some additional members, such as an edit link in case we want to modify it. And we also get back some kind of version string. In this case, you'll see there is an E tag, which uniquely identifies a specific revision of this post. The 201 response code is used to indicate that this content was successfully created on the server. So now, what is Google Data? How do I use it, this abstract way of looking at Atom feeds? Well, what would you need if you wanted to represent something that wasn't a blog post in Atom? Probably some custom XML that describes these entities, and that's where kinds come in. GData kinds are used to represent abstract ideas that come across many APIs, such as what is a location, what is a time, what is a contact, things that you don't want to have to reinvent each time you're specifying a new API or working with a different product. So once we have this XML that fits nicely into the Atom model, since Atom allows you to extend its XML, what else might you need? Well, there are some things like a query language or some authentication that we have added to Atom Pub as part of Google Data. Google Data basically allows us to fill in the cracks between what Atom Pub tries to accomplish and what we would like to accomplish using them as APIs. So as I already mentioned, there is some form of authentication that we need to have in order to work with Google services and tie into Google accounts. And we also have some way of restricting what kinds of content that you are trying to access using this feed. And then we also need some way to handle conflicts just in case two people are trying to edit the same information at the same time. And then we have these common elements to express what this information is that we're working with. And we have some other niceties as well that are not part of the Atom specification, such as batch processing and media support. So when we're making a query on an Atom feed, or a Google Data feed in this case, what is it? Well, basically it's just a URL that contains enough information to tell us what kinds of entries we're to expect. So first here we have a URL that describes all of the documents in someone's Docs and Spreadsheets accounts. But maybe all we really care about is what spreadsheets they have. So the second URL here is very similar to the first, but it uses a category query to restrict only the spreadsheet document types in the results set. And lastly, of course, we can retrieve just each individual entry and the information associated with them by passing a URL that contains some sort of document key. The nice thing about Google Data is that it has consistent features across all of our APIs, such as alternative output formats like JSON and RSS in case the software you're working with natively consumes those formats. It also has this authentication model that we'll talk about that allows you to authenticate users to their Google account and securely access their data. We've created a number of client libraries for many languages that parse all this XML and Atom data into an easy-to-use object-oriented model that you can manipulate directly in the language you're comfortable with. And we also provide some protocol customizations, like I've said, for things that Atom hasn't tackled yet, such as batch processing, in case you want to do a number of operations at once. So as you can see, there are a number of Google Data APIs out there for a number of popular Google products, such as Google Calendar, Google Spreadsheets, Picasa, and YouTube. So you can now access data in any one of those products using these same semantics that I'm describing to you. So for example, let's go through a simple way that I might, as a programmer, interact with the Google Calendar API. So first, I need some way of authenticating this request that I'm going to be making. So I have two options here. One is auth-sub and one is client login. Client login is meant for desktop-based applications that can, have the user input their credentials directly and then make the request to Google servers, whereas auth-sub is intended to allow third-party websites to redirect users to Google's login page and then redirect back to the website in question. So now both of these are going to give your program some kind of token that you can pass along with your request and make it an authenticated request. So first, let's see what we'd have to do to retrieve all the events in someone's calendar. Well, it's very simple. All we're doing is pulling down a feed, passing along our credentials, and making this authenticated request. So when we get it back, we get a 200 OK. It means this request was successful. And we get back Atom feed that says some information about the calendar, such as this is Mr. Test User's calendar. And he is based out of the Pacific time zone. But as you notice in his feed, he didn't have any calendar events currently on his calendar. So he is a very lonely person. And so maybe we should invite him to lunch. Well, here I'm demonstrating how we can create an event on his calendar by using the post semantics of HTTP. So all we're really doing is creating an Atom entry and then sending it to the feed. So as you can see, we set the start time. 11:30 is time for lunch at Google. We've set some information about it and description. And we're using this category, this kind of event, so people know that this is an Atom entry representing a calendar event. So once we've created it, great, we get a 201 created response, which means it was added to his calendar successfully. And we get back that same entry, except now you'll notice there is an edit link inside of the Atom entry, which allows us to go back and make modifications. And there is a long ID there in red, which distinctly identifies this specific event. And then you'll notice there's a version string in blue, which represents this revision of this event, which is, of course, the first one since we just created it. But you notice in this that we forgot to set where this location was occurring, and Mr. Test User isn't always very bright, so we better tell him where it is. We better edit this thing. So now we're going to use put to edit the event that we just created. And you notice we're putting to the edit link that we just saw in the previous slide. So here we're making this request to the edit link with that specific revision string that we just used, and then we're passing our authentication information, and all we're doing is putting the same Atom entry, except now we're adding at the bottom here in blue the where element of specifying that Google is based out of Mountain View in California. So now that request has gone through, we get an OK back, and now you can see the latest form of the event as on his calendar, and it has all the details he needs to find us, and he can come eat lunch with us. That's great. But you know, maybe we don't really like Mr. Test User. He kind of talks too much, and there's a reason that no one ever invites him to things. So we're going to delete that event on him before he sees it, hopefully. And so here, to delete the event, all we really need to do is issue a delete request with the edit URL that we just got back from the updated form. Now notice that I said the edit URL from the one we got back. If we use the original edit URL that we edited the event with, then that would already not work anymore, since that blue string at the end, that version ID, would be different than it is now. But since it is the correct one, we get back a 200 OK. Now if we had used the previous one, we would see a 409 conflict error there instead of a 200 OK, which meant that there is now a newer version of the event on the server than the one that we are trying to delete. So now that we've seen a 15-minute rapid-fire walkthrough of how to use Google Data using specific things, you've got the basic idea of what Google Data is and how it works on the basic level of XML and using HTTP. But perhaps, like most people, you don't want to construct all this XML yourself, and you might be more interested in the high-level client libraries we support in your language of choice. So now what you should do is go to code.google.com/apis/gdata to find out more and download the client library of your choice.